what we have here is a table of information, and you can see on the top it says survival status, and along the side it says class of travel. Turns out these are our two categorical variables. So what we're going to do today is start to learn how to analyze two categorical variables and see how they're related to one another. All right? So this is actually real information from the Titanic, right? And class of travel is one variable. The three categories you could be in, you could have been a first-class passenger, a second-class passenger, or a third-class passenger. Okay? And when the boat sunk, you would fall into one of two categories. These two. Okay? All right. So the first thing I'm asking you to do is calculate the marginal distributions. Marginal literally means that in the margins. And you can do that by adding the columns and adding the rows across. So to get the number that goes here, we're going to add 197 plus 94 plus 151. If you do that, okay, you get 442. And in the same fashion, you're going to add these numbers here and get, we get 765. Okay. And then we can also calculate the marginal distributions over here on the side. We can add 197 plus 122, and this would be the number of first-class passengers. What do we have? 15. All right. So you get 319. Then we have to do 94 plus 167. 261. And then lastly, 151 plus, what is it? 627. Okay, and then while we're at it, we can get a very important number, something called a table total. So we can get that number there by adding either 442 plus 765 or 319 plus 261 plus 627. Okay, so there we go. All right, so we've created the marginal distributions. Okay, and it's nice to have these because then when we go to do some probabilities in a little bit, it'll be very convenient to have these totals on the bottom for us to read. All right, so we did that, calculate the marginal distributions. The second thing I'm asking us to do is create a segmented bar graph. Okay, and a segmented bar graph is one of the ways where you can start to compare the two categorical variables. So this is not such a bad thing to know how to do. Okay, so what we're going to do is we're going to make an axis, right? And on the bottom, I'm going to put survival status. And up the side, I'm going to put class. Here are my two categorical variables. Okay? And you can automatically see how this is going to be different from the beginning of Chapter 4 and Chapter 3, where we had two quantitative variables. We had quantitative variables. We had x values and y values that we could graph. We don't have that here. Survival status has only two things it could be. You either lived or you died. Okay? And class only has three possibilities. Okay? So I'm not going to label these on the axis. You'll see what I do in a moment. Okay. If I look among the survival status, we'd have sort of a strange thing. If I made a bar graph out of counts, which is what this table is in. When I say counts, it means that the numbers in here are the actual number of people, right? Then you could see right away these two bars, the bar for lived and the bar for died would be different heights. You'd have a bar of height 442 for the people who lived and a bar of height 765 for the people who died. So that may or may not be the best way that you want to compare these things. So what you might want to do instead is calculate the percents that go in here. So for example, you might say, hey, of the people who lived, what percent of them were first-class passengers? And of the people who died, what percent of them were first-class passengers? So we can convert these things into percents pretty easily. So this number, we're going to do 197 divided by 442. And we would get All right, so about 45%. And then we could do 94 over 442 and get 21%. And then we could do 151 over 442 and get 34% about. And then notice how those things will add to 100 now. All right, so now we can go do the same thing over here. Okay, first class passengers who died, 122 over 765. And then we can go down the list here. 16% about. 167 over 765, and we get about 22%. And then we have 476 over 765, and what do we get? 62%. Okay, now it's always worth it when you're done to add these up and make sure they add to 100. So notice if you do 16 plus 22 plus 62, you will get 100%. I should warn you in advance, there are times when you would add these percentages and get like maybe 99%. We would round down a little bit, and that would be because maybe two of your percentages up here rounded down, because maybe they were both had a 0.4 in them. But when you added them together, they would have had a 0.8. So they would have rounded up, added together, right, if you left the decimals in. But if you rounded earlier, they would have both rounded down. So that can happen. All right. If it does happen, then you can look back at your actual decimals and maybe round one of them up or something. Okay, but it's going to be okay. It's just called round-off error. All right, so now what we can do is this. I'm going to color code things. I'm going to make first class red. I'm going to make second class green, and third class blue. Okay. So here we are. First class is 45% lived and 16% died. So up the side scale here, this is going to be 50%. This is going to be 100%. Okay? And what I'll do is I'll start with the red. We said 45% of the first class passengers lived. So there you go. So there's the 45% bar for first class passengers. If we look at the percent of first-class passengers who died, that's only 16%. So that bar is going to be pretty low. It's going to be something like that. Now, how do I know that? Because this is halfway up is 25. That's 75. So that's about right. This is probably where 16 is. Okay, so you can start to compare classes very easily now, right? You can see these two red bars. There's different heights between them. Okay, let's go back up and talk about second-class passengers when they decided to make green. It's 21% for second-class passengers who lived versus 22% of the second-class passengers who died. All right, so what are we going to do? We're going to add 21% to 45%. So if we just go over on the side for a minute, we do 21 plus 45, we get 66. So this bar has to get up to around wherever you think 66 is. So something like this maybe. Okay? And then if we look at, we said for the second-class passengers who died, there was 22% of them. So we had 16, because that was the height of the red bar, plus 22 is 38. I think I've got that right. Let me just double check. Yep, it was 16 plus 22, which would be 38. So 38 doesn't even make it to 50. There you go. It's probably about there. It might be a little bit lower even. I might have made it too big. The important thing is these two green bars, they should have sort of the same height. Because remember, this is 22% and this is 21%. As where these things are drastically different. That was 45% and this is 16%. You should expect 45 to be almost 3 times as large as 16. And it is. It looks like it would take 3 of those red bars to make the 3 of the red little bars to make this other big green bar, big red bar above lived in first class. Okay, lastly, the rest. You just get yourself to 100. You actually know the number is 34 and 62. So this number comes in. Here you go. That's 34%. And then this number came in. Here you go. 62%. Okay? So this is sort of a nice way to make comparisons right off the bat. You can clearly see there was a relationship here between the class of passenger you were and the likelihood of survival. Okay. It's worth mentioning that you could have put first class, second class, third class horizontally, and then the bars, this segmented bar graph would only have two sections. There'd be a lived and a died section for each group. You might claim that that would be a nicer way to compare things. All right, let's try and answer some probability questions. All right, so with all of these charts, you can answer some probabilities. I will say that it's helpful to have those margins in here again. Let me just remember what they were. So this was 442, 765, 319, 261, I believe, and 627. Oops. And then 1207 to finish off as a total. Yep. Okay, there we go. Keep those margins around. All right, so now we can start calculating probabilities. For example, find the probability that somebody lived. That's what this notation means. It's a compact way of saying what's the probability someone lived. Well, the probability somebody who lived would be the total number of people who lived, which was 442 people, divided by the total number of people who were represented in this table, which is 1207. So it looks like it's a little bigger than a third. Okay, so this is about 37%. Okay, now, I got shifted a little bit. Sorry about that. Here's the one I'm interested in next. This is new notation for a lot of you. You can see a vertical bar here. It says the probability that somebody lived given they're in first class. So when you see that vertical bar, you can interpret that to mean given that. Or sometimes you would say such that. Okay, I prefer given that. When you see something like this, when you see the probability of A given B, that's called a conditional probability. And a conditional probability is just, we've got to satisfy a certain condition first, and then we can start to talk about answering the question. So here's what I mean by that, really. This is saying, find the probability someone lived given they were in first class. So this is really saying, just look at the first class passengers. Out of the first class passengers, out of 319 of them that were on the ship, 197 of them lived. So this probability would be 197 out of 319. Someone might ask, how come this isn't out of 1207? 1207 is all the passengers together. And that's not what this question is saying. When you put this vertical bar, which means such that, what we're saying is, hey, just look at the first class passengers. Only look at those. If we look at just first class passengers, what was the probability that they lived? 197 out of 319. That's a pretty big number. It should be close to 60%. All right, so that's about 62%. All right, let's try one more before we go. Lived, probability someone lived given they were a second class passenger. Okay, so there's 94 people that lived and were second class out of 261 total. So 94 over 261 is about 36%. And then here's the most alarming one of the three to ask. What's the probability you lived if you were a third-class passenger? Well, 151 third-class passengers lived, but there were 627 of them, which gives about 24%. Okay.